those sort of things. So we're going to go through a whole list of things today. This is generally a fairly a kind of beginner to immediate webinar. People have asked us in the past to give them feedback on, what level this will be. There's going to be no code today. Sorry if anybody's expecting code, but no, this is more of an informational research kind of a piece that we pulled together. But ultimately, thank you for joining us, no matter where you're at. So good morning, good afternoon, good evening, and let's get this started. So first of all, it's just me today. So I'm Jim Walker. I'm the VP of Product Marketing here at Cockroach Labs, and I'm happy to have you all with me. We will be taking questions in the QA panel and in the chat. I really like the chat, actually. If you talk to everybody, say hello if you want. That's always fun. And then a recording of the slides will be available after the event. So before anybody even asks me in the QA or the chat, that's it. So again, thank you. Please do use the chat. I'll try to monitor that as I'm presenting. I have two screens here. And I'll try to interrupt myself to try to pull in some of the questions along the way without being disrupted to the flow of the conversation. So with that, let's talk about the true cost of a cloud database. So, when I think about a database, it seems like a pretty simple purchase, right? You purchase software and you purchase some hardware, you get it up and running, and you start writing query. You establish a database on that thing, and you start writing queries. And sometimes even the software license goes away because it's open source. You're using MySQL, you're using Postgres, and so it can get pretty simple. But it's not just that. When you have an application that you want to actually deploy into production, as a lot of us know, right? As a simple developer coming out of school, I thought this is it. But as we kind of mature and as we scale and we get customers, well, these things always need to be on. We need to accommodate new customers. We need to integrate with existing systems. All of these things actually add some considerable cost to the overall implementation of the database as part of an application architecture. There's a whole bunch of other things that actually come into into consideration as well, and they aren't as you don't think of them up front often, right? And it's how do we actually make sure our developers and our DBAs are productive, right? All the people that have to use the database or interact with it. How do we quantify the cost of planned downtime and unplanned downtime, even worse, right? Which is kind of related to the disaster recovery up front, And if we're deploying on the cloud, how do we ensure utilization across all of our cloud resources so we aren't wasting time, right? So these all kind of different types of costs that are associated, but there's more. How fast can we deliver applications? Do we need to scale this thing to be global? Are we using databases that are going to attract the right talent to come work in our companies? How do we deal with data privacy and compliance? There's huge risks associated with the database when it comes to these sort of things, right? Loss of customer if we lose their data. Loss of confidence. From a compliance point of view, if we look at laws like GDPR, these things have teeth. And so how do you quantify and how do you measure some of these risks and true nature of what the database costs? And, from one being a kind of a simple, straightforward cost actually is much more complicated than one might think underneath the covers, right? And so there's this kind of these hidden costs, if you will, that aren't always upfront and forward with everybody that are actually pretty important and should be taken into consideration. Now, for me, anybody who works with me understands I love rubrics, I love structure, I love kind of going into these things. So, if I took a step back and kind of thought through all the different ways that people are thinking about these sort of things, I've broken this out into 4 buckets of areas that one would want to think about in terms of cost of a database. All the baseline stuff, some of these more advanced things, all the management aspects of a database, and then some of these hidden things or the obscure costs is what I think I like to call that last group. They're a little bit less forthright and upfront, but they're also very important. So what I'm going to do now, I'm going to walk through each one of these different cost items or line items, I guess, of cost, and just kind of talk through what some of these costs are in a little bit more detail. And we're going to follow it up with basically, this is Cockroach DB and Cockroach Lab. So a small commercial at the end in terms of how we actually deal with some of these things and how we can actually help mitigate some of these risks as well, right? And so I'm going to use this rubric to actually help us through this conversation. But let's start off with the database itself and the software license. Now, In a traditional setting, this enterprise software, gosh, as far as I've been in enterprise software, there was this initial purchase for hundreds of thousands of dollars. Your sales rep then makes you pay this 25% support and maintenance fee. And then often, there's an upgrade from version 8 to version 8i or whatever it is, and you got to go and pay for that or whatever it is. And then there's often add-ons for added functionality. This has been a model for 20, 30 years in enterprise software, and before the cloud, right? This is where you just bought things and you deployed it yourself. Commercial open source came around about, I'd say, really in its reality, about 10, 15 years ago, and as a viable solution for enterprise organizations. I personally was at a company called Talent. I was at a company called Hortonworks. I was a company called CoreOS. Running this commercial open source game to the enterprise and actually selling software was very interesting, right? Because typically it's free to start. Anybody goes and downloads it. But a lot of people actually need support and maintenance. They want, upgraded features that are beyond the pure open source part, right? And they'll go to a company to actually get that from them. They may be still using the free software, but they need support and maintenance, right? And then there's kind of open source software, just general, where it's like, yeah, is this free beer or is it free puppy? You kind of go on and maintain these things. And so community support becomes a very important thing. There was a question about the traditional enterprise software license and what is that 25% cost? Typically, that's 25% of whatever your initial purchase was. So, say your cost basis was, for the software itself, whatever. Let's just say, I don't know, Jim's database costs $100,000 for whatever you're buying, the scale that you want, and then your overall would be really 125,000 because they would add typically a 25% fee, ongoing annual, 25K in the first year, 25K in the second. The 100 would be amortized over the first year, right? Or whatever the length of that contract is, right? But that 25% would typically be off of that initial purchase price. That was a question that came up. So there's also a question in the chat. Like I said, I'm trying to do both here, y'all. What about admin burden costs like maintenance and upgrades, debugging? Is that captured here? Absolutely. We're going to cover that in a couple slides. So, but let's finish off and tie off on just the license alone, right? One of the important things to understand in terms of database software is that there is a huge, massive risk, especially in adopting open source software. And this is kind of one of those those unknown risks that people don't always think about. And there's a concept called indemnification. And what indemnification does is really kind of cover you from the risk of a lawsuit. A lawsuit that the software that you installed causes some sort of problem, or exposes information, or there's lots of different things that would come into consideration. But typically in open source, you don't want to be exposed to some sort of risk because you adopted some software that's now running in your organization. So indemnification is typically a large vector in which people think about when they're thinking about the database software license and what they're paying for. Definitely in commercial open source, that's a big piece of it. And not to be underestimated. I think it's an important part of your cost equation when you're thinking about adopting software. And then also, a lot of the, so traditional software, commercial open source, both offering support and maintenance for the software itself. Be wary of some of the cloud services off there that only offer limited support, knowledge base, or limited channels, or community only. Typically, the traditional enterprise and these kind of commercial open source companies, they will offer, full on, SLAs with, P1, P2, P3, or priority one, SLAs, so service level objectives, in terms of how quick they're going to actually respond to you. That's another reason why people actually do this, right? It's going to eliminate the risk and the cost of them having an issue for too long, so they don't lose customers and everything else, right? So there is a whole lot that's actually wrapped up into the software license itself. So be wary of support. It is actually a really, really important piece of these software licenses and something to be consideration when you think about the cost of the database itself. So let's move on to hardware. So, I don't know, when I first bought my first database on a big project I was working at, gosh, I was at a consulting company. We were consulting in this huge telecom out west. And, our basic equation was, okay, how big of a box are we going to be able to afford? Well, we took our project budget, we took the software cost, which is in red for a reason, and we basically subtracted that from the overall budget cost, and that's how we figured out how much we could spend on hardware. And the hardware was really how far we can go, how far we can expand, what scale in terms of transactional volume and size of the database we could possibly go. That's kind of how it used to work, right? Today it's very different. We have moved on. This is a different equation, especially with the cloud. And so today, well, you're still doing some stuff, on-prem in your data center. You're setting up your own cloud. You're running on OpenShift or OpenStack. Oh gosh, man, I always mix those two. Whether you're doing an OpenStack or whatever you're doing, you're typically running your own cloud on-prem, but you're still purchasing hardware, or you're renting it possibly. There's lots of different things involved here. You're negotiating prices with a vendor. It could be a cloud provider. It's your own on-prem. There's lots of different ways to do that, but you're still tasked with deploying and configuring these things, right? Now, when you choose a public cloud provider, well, you're just basically choosing instance types, right? You are actually negotiating prices with that vendor. Some organizations have, economies of scale because they have huge brands that, say, a public cloud provider would want, but you still need things like load balancers, and there's just certain things that are kind of application specific that you do have to think about when you start thinking about the hardware, especially in the context of a database. But you still need to manage and operate all these. The operations doesn't just go away. There is considerable time spent in the interfaces of these cloud providers to actually manage these things, and understanding from an operations point of view, integrating them in with how you actually operate and deal with all of these things is actually pretty important. So so let's move on from hardware. So let me just finish out on hardware. I get asked this a lot. Why do companies choose to go to the cloud, and what is this OpEx versus Capex thing? I kind of felt like it did actually belong here, because this is actually your overall cost equation in running things, on your own servers in your own house, or running things in the cloud. There's a huge argument for, moving things to an OpEx, with operating expense versus capital expenditure, right? And so the difference between the two really is that when you buy items in Capex, you've bought it, you own them, you're responsible, you're in it for the long term. When you buy and purchase as OpEx, basically it's a subscription, you're renting, somebody else is really responsible for that. And the way that you recognize the cost in your balance sheet as an accountant is, with Capex, you amortize over the lifetime of that item, whatever it is you bought, right? So it could just take a long time for you to actually do that. With OpEx, you're basically amortizing for the rate of the subscription. So it's kind of month to month. Like, I can go up and down in my cost pretty easily. And I can basically vary my capacity a lot easier with OpEx as well, because it's a lot easier. With Capex, you just gotta buy it as far as you wanna go up front, right? And so OpEx, operating expenditures, give people a way to kind of mitigate risk and to become more agile. And this is, to me, what's driving this entire movement to the cloud and everything that we're doing, right? And so, this OpEx over Capex thing, I think is a really interesting conversation. I should have added, there's a really good article that I wish I would have added. I don't know if somebody from the team here that's on the webinar, if you guys go in the sales channel and dump that into the chat, that'd be awesome. Maybe somebody on my team or something, that'd be awesome. But there's a really good article that actually goes into this. I just posted to the whole company, and it helped me understand a really whole lot about this equation. All right, moving on from hardware. But before I move on, there was a question. How does an organization protect itself from indemnification? Well, actually, indemnification is what protects them from some sort of lawsuit. What happens is when a vendor, the enterprise software vendor or the commercial open source vendor, when they sell you a license, part of that is indemnification. And that indemnification is basically some level of protection up to like $1 million or $5 million in terms of a lawsuit against you as a company. So you, the question asker, if you implemented that software and you got sued, well, the vendor is going to cover you up to X amount. It's basically an insurance policy. That's really what it's all about. So, okay, I hope that answers your question. But it's actually, it's one of these things. Actually, when I started to understand it, I started to understand a whole lot about commercial open source, because that's actually a really big piece. So, all right. So let's move on to some of the more advanced costs. Wow, lots of, look at the teams all over it. And did you guys, can you guys, let me make sure this link can go to all attendees. It went to panelists. There we go. There's the link going to all attendees. So I think they just sent it, but you guys can only send to all panelists. So forgive me if you can't, I'll talk to yourselves. So then there's, when you are implementing or choosing a cloud database, it can get complex. We are asked to compare ourselves against Aurora or Spanner or, RDS or, whatever. Like, there's lots of them out there. It's funny, my sales guys are like, Jim, I need a direct comparison between. I'm like, it's not a direct comparison, because we're wrapping a lot of these costs into one single price, which is good and bad, right? Because we are choosing basically the amount of IOPS or the amount of storage that we're offering, right? Making it really simple for people. With other cloud providers, you are choosing the amount of storage. You are choosing IOPS. Now, IOPS is an interesting one. It's input output operations per second, or whatever that stands for. It's how many times you're going back and forth between disks. Now, these sort of costs can scale out of control very easily if you aren't aware of what they are. It's kind of like when you leave that instance on, you forgot about it for 4 months, and then all of a sudden you have like this big fee. Like, these things can happen. I'm not saying that it happens all the time, but like, it's something you have to be aware of, right? Because these things are variable. Some of the cloud provider offerings also charge you a lot more for multi-region. It's a wholly different type of implementation or service, or they'll charge you for backups, which is basically storage. And like it or not, organizations and definitely highly regulated communities do actually have to have the concept of backups going on as well. So these are just more costs you have to be thinking about. Okay, so come on, slides, there we go. Okay, so then there's disaster recovery, and everything fails. We all know it, it's inevitable. These are mechanical systems. Everything mechanical will fail one day. Nothing lasts forever, period. Your database will fail. And there's a whole reason why this whole kind of context of an active passive system has set up, right? It's like, look, I need 2 data centers. I need an active database in one, and I need a passive system in another AZ or in another region, right? In case, what do I want to survive? Right. And so setting these things up is not really that simple. It seems simple, but it's actually, it's very complex. And so how do you synchronize these 2 active passive systems? How do you make sure that the data is correct in both of them at all times? Really, really difficult. And then just the synchronization, asynchronous, can get complicated. What happens if that wire gets cut between the 2? What happens when I start to, shard these 2 environments, or I do some sort of considerable upgrade to that database? How do we keep them in sync, right? And then just the cost related to having 2 massive, huge servers, because look, scale is also difficult, and that's going to be the next slide. Like, how do we scale a database? Well, typically people just like, well, I'm going to buy a bigger machine. Well, when you do that, well, you have to buy the same similar bigger machine for your passive setup too. So your cost, when you just want to scale up, actually doubles, right? Because you have these active passive systems. And then, oh, by the way, the synchronous, if you want to actually survive multi-region, you want to have, an active passive when, let's say US East, US West, whatever, the egress cost between these regions actually is gonna cause you a considerable heartache from a wallet point of view as well. Egress being the cost of moving data across the boundary of a region for a particular cloud provider, which is often an issue as well. And then there's backups. Backups is storage. How are you doing these backups? Where are the backups happening? You have to manage these things. And it's just yet another cost when you start thinking about the database. So here we were, a simple developer. I just want to build an application. I am 4 items in here, and I've already thought through a whole bunch of stuff that is actually pretty important to think through. So as I said before, you're also probably going to want to scale your database, right? So if anybody here on the line has ever said sharding is easy, I want to talk to you. It's not. This is not something that's really simple to do. So what many of my friends have done is just, well, I'm just going to go buy a bigger machine because the sharding is so difficult. Some implementations, however, you can only go so big on a bigger machine. And so they actually result in kind of this manual sharding process, which is difficult to do. Just the analysis to make it happen is difficult. The required downtime to implement this, which we're going to actually cover in an upcoming slide, right? So planned downtime can result in loss of business. There is, again, additional hardware. I actually now buy 2 machines in one zone, but I'm going to need 2 machines in another zone because I have this active passive thing. So I've actually now doubled my capacity in terms of the hardware I have. This complexity that it adds to the application is also a cost that can't be underestimated. Now that I have, 2 shards, are there changes in my application logic to make sure that I'm actually accessing the right data? Even if you put something in between, some sort of shim to automate that, it's still yet another layer that you have to put in there, right? And so it's really kind of difficult to do. Scaling is an issue. And so, well, I'm at Cockroach Labs, so automating this one is one that we focus a whole lot on. But they will require downtime, and it's just yet another cost. So then there's integration costs, and I kind of call this, it's part of the core concepts of advanced and base, because really no database just lives by itself. It's going to be integrated into other parts of your IT platform. Architects and data architects and CDOs and CIOs and these guys, they think about this stuff all the time. Like, you aren't going to run OLAP in an OLTP database. There's a reason why data warehouses came about, and so integration between your database and putting that into the data warehouse for whatever reason it is that you actually run analytics on that is actually, there's a cost. Do your use cases require Kafka or some sort of stream processing? Are you using a data lake? Like I said, I was, old Hadoop guy, right? Like these things, how do you integrate with these things? And then there's this whole concept of data science and these databases. So each of these integrations costs, not just from the technology on the other side, but the resources to get it right. The data integration side. Understanding the data back and forth and the people that it takes to actually think through that integration. Now, yes, that's kind of around the database for sure. I absolutely agree, but I think it's important so that the database itself is going to fit into that integration, right? You've got to, like, the more the database fits, the better off you're going to be, the better off you're going to mitigate these sort of risks as well, right? So. There was actually a question here, and you are my favorite attendee. Another question. So isn't scale a non-issue if you're on a public cloud? Yes and no. Scale in sharding and getting horizontal scale, buying bigger machines. Yeah, some databases and some services do allow you to scale out. Typically, they'll allow you to scale reads, but often people need to scale writes as well. There's this concept called multi-master, or, how do I allow more than 2 nodes to write to a single database? That's really difficult to do. And that's not to be underestimated when you start thinking about scale. Scaling reads across an entire planet is fairly simple. Scaling writes is really difficult because you basically ended up in a situation where you're either going to have to deal with some sort of latency where everything's coming back to a single node, and we're going to talk about latency in a little bit, or you're using the database and you have to make sure that that database is consistent, because the primary rule of database is I don't want to lose data, right? And so how do you ensure that it's going to happen? And if you're doing some sort of system of record thing where it's financial transactions, if you have 2 write nodes and they aren't in sync and they aren't locking transactions, however they're going to implement that, you're going to have fraud. And so we're going to talk about that a little bit more. But scale is, it's definitely less an issue when you're on a public cloud. I am not underestimating that point, and I appreciate the question as well. So, all right, so ease of use for the DBA, it's not. This is kind of the management side of things. I think, there's 3 kind of roles that deal with the database at all times. It's that DBA, it's a developer, and it's DevOps. For me to just pass over one of them, I think would be an injustice to the database, because I think they're all very important in the context of when you choose a database, and are they going to be able to do their job, right? So, for the DBA, is this standard SQL where I can go out and get DBAs all over the place and they're familiar with it, and the DML they use is going to be similar from one to the other. Do they have cost-based optimizers because they're used to that? Can they do query planning and investigate queries and optimize queries and this sort of thing, right? Because that's what they want to do, right? They want to ease this management of the overall system. So when choosing a database, well, it should be fairly easy for a DBA to use, and all the tools they use should integrate with it as well, right? The ones that they're familiar with. Now, look, this is not a huge cost center. I think it's more of a concern and a risk. And I think it's just something that people should be thinking about when they actually adopt a database. Now, when it comes to development productivity, the app developer, well, I'm happy to have this debate with anybody at any time. If the database doesn't speak SQL, I think you're going down the wrong path. It just, look, and there's a lot of SQL databases. If you're going to make people learn a new language, it's just the amount of developers you can have working on that application is going to be limited. And you're asking them to learn a new language. I can't speak French. I can order dinner, but I can't get complex conversations out of that, right? And so, if you want developers to be productive, I think, understanding that this is SQL and it's not some weird version of SQL, it's standard SQL, the closer we can get, I think it's really, really important, okay? And so I think it's just the developer productivity to me is just really difficult to estimate the cost of that, but ultimately extremely important. And let me just say with a caveat too, like depending on your use case, like graph databases are amazing. And so if you think about languages that you're interacting and how that works, and well, yeah, your use cases, but I'm talking about, the OLTP databases, mostly relational databases, mostly. I think some people are trying to use some of the NoSQL databases in the way, and some of those NoSQL databases don't speak standard SQL. And I think it's just something to be concerned about. So actually somebody asked me, am I going to share the slides? I will absolutely share these slides at the end of this. And I'm more than happy. And I am going to be very happy to get input back from everybody as well. Over the next month, we're also writing a paper that hopefully will be beneficial for everybody. But if anybody has any input on the slides along the way, and I'll say this at the end as well, and we share them with you, please do give me input so that we could make the paper as great as it can be. So this talk track hopefully will be available for you to share with other people in that form as well. And then this final persona that deals with the database is DevOps. Look, DevOps has transformed the way we think about application and really the way that software gets delivered into production. This introduction of CI/CD has just created massive, huge efficiencies. How is the database part of your CI/CD workflow? And I think we could do that today. There's a lot of artifacts that are managed just like applications within your CI/CD workflow. But what about things like stored procedures? Are we putting those through the same sort of rigor where we're checking them in, checking them out? From a code repository point of view, do they work in the same context as the rest of your code, or are they kind of baked into the database artifact, right? Are you getting the efficiencies that you need from testing these things from a CI point of view in the overall context, so you can mitigate some sort of risk as changes come to these things, right? And so I think it's also very important. And then finally, I think, look, a database should not require some sort of advanced degree to manage it. I shouldn't expect my DevOps guy to learn these huge, massive, crazy concepts. I think they should know some basic things and be able to manage the database itself. So if it requires a PhD, you're asking your operations people to do some pretty heavy lifts, right? So, and then finally, there's this concept of the SRE. I think if I just simplify this whole concept, does the database implement some sort of very simple, easy to use API so that the SRE can automate? Because the SRE is really the systems reliability engineer is really all about automating everything, and they use APIs to do that. So how do we get these people enabled? Because if you're using the wrong tools, they're hard to find, and you may lose them, and they're difficult, right? So also a concern. Okay, so planned downtime, unplanned downtime. Again, look at everything is going to be upgraded at some point. Databases will need to be upgraded. Schemas will change. Everything will go through some sort of change over time. There is no perfect sort of software ever. And maybe my Hey World that I wrote and my computer science 101 course, that thing still works. But beyond that, even some of the other ones, I wanted to, upgrade them and, make a blinky tag or whatever. As you change applications, you're going to have some sort of planned downtime, typically with a legacy database. And so you typically will schedule these things in the middle of the night. Now, what does that cost you? Okay, well, it might cost you in a loss of customer or some sort of issue, right? Because somebody came to your website and your system or your application was not available. So we do these things in the middle of the night so we can minimize that impact. Nobody really wants to do these things. You know, you're not going to do that in the middle of the day. So you're going to do that in the middle of the night. I don't think anybody really likes that. And then when something goes wrong, and I say when, you're going to have to roll back and start over. And so you're basically redoing that entire thing. And so how do you mitigate this one? This one's tough. There's a concept called rolling upgrades. Some modern databases and modern systems do this. It allows you to basically do upgrades in production. So, you know, let's do an upgrade on Friday afternoon. Sounds good. Yeah, it's possible. You know, I wouldn't totally recommend it, but you can mitigate some of this risk, right? And so I think it's a cost, and it's resource and risk cost more than anything. But there is a little bit of a risk in terms of loss of customer because you are going to have that downtime, say in the middle of the night, right? Then there's unplanned downtime, and you know there's a website I find interesting and enjoyable called downdetector.com. I think that's the name of it. I'm pretty sure that's it. But it just shows you downtime for major services across that you all know of, like, I don't know, I choose your big company. I don't want to upset anybody on the phone today. But everything goes down. Everybody has unplanned downtime. I mean, if you look at, you know, GitHub is probably one of the most visible to maybe this crowd. You know, GitHub had an outage 2 months ago. They had a really big one 2 years ago. And it was all related to the way that they've sharded MySQL, I believe. And don't, if you're on the phone and you worked on that team, oh gosh, I'm sorry if I'm getting this wrong. I don't want to like totally dismiss this, but you know, having downtime, you know, look at GitHub is you know, pretty much a standard, but like that's all, you're all source code. That's a problem. That's a problem for customers. You erode confidence in your service. I think we're all still pretty confident in GitHub, but I will tell you that the resolution of basically downtime of, you know, an hour or downtime of even 5 minutes, when you consider the amount of traffic that's going through that system, is considerable, because how do you remediate the differences between this active passive system? So say a system goes down and it takes me a minute to bring up the passive system. Okay, so first of all, in that 1 minute of time, I may have lost data. Now, I have customers who are upset because I lost that minute of data, but even when I bring up that passive system, while I'm fixing the old one, the new one is running. And so they get out of sync. So for maybe 4 or 5 hours, how do I remediate the differences between these two systems? And think about the amount of transactions that's going through a system and how much time that takes. So the remediation of 2 out of sync versions of the database is really not to be laughed at. That is a considerable cost, and typically manual, very difficult to deal with. There's these concepts of RTO and RPO. If you're not familiar with them, you know, read about these things. I love them as kind of, you know, concerns. There's RTO is basically how much time does it take that you're actually going to be offline? You know, is it 30 seconds? Is it a minute? Is it 4 or whatever? And then RPO is, what's that recovery point? How much time does it take between that active and backup that will be out of sync, right? And so that's also important to this remediation time. So people are also often thinking about these things when thinking about the database. Finally, in management is cloud utilization. So, you know, how do we distribute data and load across multiple different nodes, if you will, or multiple different servers to even out the amount of utilization of, say, cloud hardware? How do we, when I do that, am I shifting IOPS and am I adversely affecting egress in and out of data centers? This one is a little bit difficult to kind of, you know, analyze, because, you know, it's a bit more advanced, but the more even you could keep utilization of all your backend hardware, well, the better, more predictable your cost is going to be, and it's easier to actually keep things down, right, over time. Finally, moving into some of these hidden ones, agility and speed. Again, I talked about this a little bit earlier, but how quickly can you make changes to your applications, build, test, and deploy them, right? Schema changes are going to occur. Application logic, how much should be handled by the database? Can I move application logic that was in the database out of the database? You know, I talked about stored procedures and your ability to actually change these things. You have the Do you have, experts that can actually do with those things? That actually affects speed. They actually do make sense inside the database as well, because you can optimize them even better, right? And so there's this kind of like mix around agility and speed, but it's actually pretty important. The one I like to talk about is schema changes and how they actually change downtime and introduce risk in the whole conversation. So it's also kind of important. And then there's latency. Latency Latency is one of these things that we focus a lot on here at Cockroach Labs. I don't think everybody totally gets it, but there's this gentleman at Google, Paul Butchite, and he came up with this concept called the 100 millisecond rule. And the 100 millisecond rule basically states that that's the amount of time that it takes for an interaction with a computer system that doesn't seem instantaneous, right? So at 100 milliseconds, it seems instantaneous to everybody. Well, when you're dealing with latencies, say you have a user in Sydney and they're accessing a database that's over in Richmond, well, it's got to get to the West Coast and then clear across country. Oh, and by the way, it's got to return all the way back. We're dealing with, what is that, 440 milliseconds? So that doesn't seem like an instantaneous reaction, right? And so while this isn't important for every single application, when you start to deal with global latencies, when you start to deal with these things, it actually becomes very important. And as we move, and as the world moves towards 5G, and always on instant services everywhere, this is going to be more and more important. And I really believe that this 100 millisecond rule and Paul will be infamous because this is a challenge. And so even if you're dealing with users in say just the United States, you have instances on the East and West Coast, you're still dealing with these millisecond delays because often transactions take multiple different interactions with the database, right? So you can actually compile a 70 millisecond interaction with a back and forth. Okay, that's up to 140, and then say it takes 3 different interactions with that database to actually commit. You're actually starting to push the limits, and you need to start thinking about these latencies because ultimately, it's not just the reads that matter; it's the writes as well. Before somebody asks, yes, you can put a read-only copy in another region so people can just read things. That works. It's awesome. It's a great architecture for your database. But what about writes? And writes does get really, really tricky when you start to have multiple instances, as we spoke about before, right? And so, these things are not simple to deal with. And as you go global and as you have, widely dispersed, applications, ultimately, this whole loss of customer thing becomes an important deal because people will typically just set up a database in Sydney and a database in, say, Richmond, and just have at it and use synchronization. Well, that will open you up to fraud and attacks because I could be hitting both databases at the same time on the same account, and depending on what the data is that you're trying to store and deal with, can lead to consistency issues. And so there's a risk associated with that as well. Talent, also important. I think most, younger developers want to work on really cool tech. So it's, like I said, it's way down on my list, but also pretty important. Having the latest technology for people to deal with is actually will keep people happy and attract people to work at your organization. Freedom, I think about in 3 different ways. I think architects and developers, they want the freedom to use tools that are going to allow them to accomplish what they want to accomplish. They don't want to be beholden to the tool that public cloud provider has. They want to actually have the best tool. I also believe that databases, should work both on-prem and in the cloud. So if it's a proprietary database that works only in one cloud, well, you don't have that opportunity to be hybrid, if you will. And there's lots of use cases that require that. And then finally, people talk about vendor lock. I don't believe in it as much as as I think the concept of it is important. And I think people want freedom. I believe that people want freedom to move their apps and services between different places if need be, and I think that's that freedom and to not be tied into a particular vendor with their data itself, because data has gravity. Don't get me wrong, but that freedom to actually use whatever tool I want is the one that I think is the most important. I list that one first, right? And so and the importance of that is how do you keep up with your competition? If they're using better technology, does that give them a significant competitive advantage because you're now tied to a cloud vendor or cloud provider that does not provide that technology or provides some weird version of it that they use the open source and did something to it and they're out of sync by 2 years or whatever? There's lots of different reasons here, but the cost of that is basically maintaining competitive advantage and then this cost of switching and the technical debt that might cause. Or if you do have truly an application that run in multiple clouds, could you negotiate better prices with particular cloud providers? And so having things that are multi-cloud or cloud neutral opens you up to at least having that conversation, which I think is something that's pretty important. Okay, last two, data privacy. It's paramount. I think every business has this concern. As a consumer, I have this concern. I look at my, my credit report all the time, and it's like, oh my God, your data's on the dark web. It freaks me out. I don't like the companies who have lost my data. I find it irresponsible. Probably not they directly did anything, bad, but these things happen. And so being able to protect data, being able to have it reside in places that are, protected, whatever that is, these things can result in loss of confidence, loss of customers. Often there's government fines associated with this. We saw that happen here in the United States with a large company. But these impacts can be devastating, especially to a smaller organization, not to be dismissed. And this comes back to security. And really, I think the second part of this, which is compliance. And, I think governments around the planet have put regulations in place to control the use of data, not just to protect the privacy of people, but also the security of this data as well. And there's like two sides of the same coin. And these laws have teeth. If you look at GDPR and, there was a lawsuit against France, I think it was for $9 million or something like this. I forget what it was. We can look it up. But these things do have teeth. And, I think there is associated risk with compliance with all of these regulations, and the amount of regulations that are happening is only accelerating. There's more today than there was yesterday. And so how do you deal with this in the database? It's going to take you resources, because are you going to have to work some of this into the application layer? Are you going to have database instances in region to make sure that data lives in certain regions, right? So, some jurisdictions require that, all data for people of my country lives in my country, and it can't live somewhere else. Well, you need a database instance in that region. So let's go back to, how do I synchronize that database with the others? How do I make sure that data in that is only available there? Okay, wait, how do I work that data into my data warehouse? And from an OLAP point of view, how is that going to, okay, wait, when I do backups, am I backing up everything or just that one? It gets really, really complex. And these compliance issues are not simple. But how do I route data to where I want to go? And every one of them have ramifications and potential risk for organizations. So when I think of everything, right, all of these costs, this was the true cost of a database. Yes, I can take the first 6 and say, yes, these are very, very hard costs, very easy to measure, or relatively easy to measure. And then, the last set, this the second half of them, I think this is some of the stuff that people don't always think about. I think it's not top of mind, but I think they're important. And I think they're important to deal with when you consider a database, because there is risk. There is actual costs associated with these things. Can I do easy math for each one of these vis-a-vis each one of the database providers? No, I simply, it's just, I'm not going to create a calculator for these things, because I think it's a different equation for every single organization. And it's really important to take care of all these things. Now, thank you all for joining. I have to give you why these things are important to us. And at Cockroach, the way that we think about these things is very different than other databases. And we do believe we built a highly evolved database, because it does take all of these things into consideration. So this is my commercial. Please stick around, right? So first of all, software, hardware, you can run Cockroach on-prem or Cockroach Cloud with full live support. So there's no added on support. With us, it's pretty predictable, straightforward pricing. With Cockroach Cloud, we actually integrate all those variable costs into one price. And then we automate scale and resilience. One of the core pieces of Cockroach database is that, this whole concept of scale and resilience, it's a cluster. Point another node at the cluster, it's going to scale. There's no need to do manual sharding. Simply spin up another instance and you're good to go. And it's going to deal with the reads and write issue that I talked about. Every node in Cockroach is both a read and a write. So we're actually going to deal with the consistency issues in a very intelligent way. We have lots of webinars on that if you want to get more, but it's highly resilient. You design the database to actually survive what you want to survive. You want to survive the failure of an AZ, a region, whatever that is. It's all actually configurable at the table level. We implement familiar SQL, so your developers will like it, your DBAs will like it, and it integrates with tools. We have query inspection, we have CBO, this active database. We're going to ensure uptime. We do provide online schema changes. So if you wanted to change the schema of your database, including the primary key, we can do that online in a production database if you wanted to. And I think this concept of rolling upgrades is awesome. The whole context of Cockroach is we are a cluster. So you can basically take, and we can have, I think, 2 or 3 different versions of Cockroach running in a single instance in a single cluster. So different nodes could have different versions of Cockroach running. And so you basically bring down a node, bring up another one on the new version. You bring down the next node, bring it up on the new version. So you can actually upgrade the entire database online. So not only doing schema changes so the application can change, but also upgrading the database itself without any downtime. So this whole basically planned downtime thing goes away. And then the final group, the hidden ones, all nodes in Cockroach are read-write nodes. So you can scale, you can go everywhere. So this whole instance of having a node in Sydney and something in Richmond and dealing with the conflicts of rights, that goes away. We deal with that. We deal with the transactional conflicts. We implement serializable isolation in a broadly distributed database, which is pretty awesome. This is a modern database. We feel it's fairly evolved. We're aligned with microservices and Kubernetes. I think people want to work with these technologies. We were a database that was purposely built for distributed systems like Kubernetes. And then finally, this geo-partitioning thing where we can actually tie data to a location based on any row of data at the table level. So all records that were created in Germany live on German servers. Yet when I want to access that and I'm asking for the record, say I'm in California, the database, if I have nodes in all over these places and it looks like one logical database, it knows where to go get that data, which is just awesome. So geo-partitioning is a key feature that we created that allows us to meet these regulation compliance things, but it also allows us to deal with the 100 millisecond rule. I can tie data to a location so that I know that users in that location are actually going to have a lower latency access to that. I can have data follow a user now. And so that's really, really powerful. And as I mentioned, as we move towards 5G, and as data becomes global, as latencies become more important, it's actually becoming a really, really important requirement for a lot of people that we're talking to. And then, of course, Cockroach DB is cloud neutral. We could run it anywhere. I could spin up a node on this cluster, I could spin up a node right now on this laptop, pointed at a cluster, and it's going to participate in that cluster. I could actually be multi-cloud. So finally, quick cost comparison. So I went through all of these different sections, and I'm going to break it down into different types of database. So a legacy database, so proprietary open source, you got to buy hardware, you got to get the license. And then there's the support thing, which is that extra 25% with open source. Okay, it's maybe optional. You got to actually have operations in place. You got to sort out with the high availability. And then if you want multi-region and compliance, well, it's a wholly other added cost. With a lot of the cloud database services, what they do is they collapse the hardware and license into one thing. If you want HA, typically it might be within that cloud service. That's why there's a dot around it. But you might have to actually deal with that manually yourself. You're gonna have to watch out for support. Now, not all of them are the same. Some of them actually do provide, pick up a phone and call support. But multi-region compliance is definitely an add-on for most of them. And then remember, you're gonna be locked into that cloud provider. So I'm not sure what those costs are. I put it in a dotted line, but I think it's something to really be concerned about. But with both of these, there's these other costs that I can't even start to mitigate or put exact numbers on. It's this downtime stuff. It's cloud use. It's the agility, attracting talent, and this data privacy and compliance thing. I don't know what that's going to mean for your organization, but it's something that should be considered. This is what I mean. I can't put this into the calculator into a neat little box. But I think there are a lot of things that you can put into a box and start to compare, side by each. So finally, Cockroach DB, our self-hosted version, which you can go and take today and start using, or use our enterprise version. You get hardware, you spin it up. We have license and support. HA all included in what you buy from us, and then you have to add operations. You operate that thing, but we also have Cockroach Cloud, which takes all that and simplifies it down into one bucket. But we choose the hardware and run it for you, and we have SREs and everybody kind of working on that for you. So I highly recommend trying a Cockroach Cloud. We are giving a 30-day free trial for that, and so I think it's kind of, you know, I guess I wouldn't be giving this presentation if I didn't think it was cost effective to actually use our software itself. But so with that, I did want to just say, yeah, there's 3 ways to adopt Cockroach Cloud. There's also Cockroach University. If you guys want to actually learn more about Cockroach Database, it's a free online learning platform. Lauren and Will do an amazing job. You know, pass the exam, get a certificate. We'll send you T-shirts and whatever and all this stuff. So it's really solid, and I think we get some really great feedback on that if you want to learn more about Cockroach. But with that, I just wanted to thank everybody. There were no questions. I got one ask, you know, so somebody said, good presentation. Thank you so much. That really means a lot to me. I put a lot of thought into this. I hope it was valuable to everybody. I'm trying to be fair in terms of all the things that we would think about in terms of what we have to think about when we're choosing databases. Of course, I am an advocate of Cockroach Labs and Cockroach Database. I believe in it. I work here. I would hope everybody tries it and checks it out. But I hope that this presentation, regardless of the slight cockroach slant at the end, was valuable to everybody. We'll make the recording and the slides available to everybody. Also, you know, reach out to us and we'll interact. And again, this will all come out in a paper in the next 2 or 3 weeks as well, so that you can share this, and the recording will be available as well. So with that, thank you everybody for taking the time and spending your time with me today. And have a great, is it Wednesday? I don't even know what day of the week it is anymore. So thank you everybody.